So I want to look at an example here and show you how you could easily convert from binary to decimal and decimal to binary. I've included a chart here. This chart only has 8 columns. Why only 8 columns? The reason why is because with IPv4 addressing, we'll ever only have to deal with 8 binary values in each of our octets. So remember that with an IPv4 address, you will end up with 8 binary bits, followed by 8 binary bits, followed by 8 binary bits, followed by 8 binary bits, all converted into decimal. So this chart here would be valuable for this one. And then we'd have another chart for this, another chart for this, and another chart for that. So that's really what it boils down to for us when it comes to our IPv4 addressing. Breaking up each of those octets into these 8 different binary bits using a chart. So since we're dealing with binary, we're dealing with powers of 2. So we have across the top 2 to the power of 0, which is 1. 2 to the power of 1, which is 2. 2 to the power of 2, which is 4. 2 to the power of 3, which is 8. 2 to the power of 4, which is 16. 2 to the power of 5, which is 32. 2 to the power of 6, which is 64. 2 to the power of 7, which is 128. So what I've placed here is our decimal equivalents of each of the binary bit positions. That's what that means. It's the decimal equivalent of each of the binary bit positions. So when we're dealing with binary, you often hear the terms 0 means off, 1 means on. 0 means off, 1 means on. So in this case here, since I have a 0, then I really don't care about 128. It's not going to come into my calculation. Here, same thing. I have a 0. That's not going to come into my calculation. But I have a 1 here, so this will come into my calculation. This won't, this won't, this won't, this will, this will. So that's really what it boils down to. Ultimately figuring out what is going to be involved in my calculation and what is not going to be involved in my calculation. So having this chart is going to help you out extremely when you are trying to figure out what is the binary value of a decimal number. So for example, we're going to start off with 35 here. We have a value of 35, and I want to figure out what the binary is. And we already know what it is because it's listed on screen. But let's just walk through this together. So first of all, I'm looking at a number of 35. Do I need this bit on or off to create 35? So what combination of ones here is going to give me 35? That's what I'm trying to figure out. What combination of ones is going to give me 35? Well, if I have this as a 1, then I'm already at 128. That's too big. That's way too big. So that's why down here in our chart, you can see it's identifying for us that we're going to go 2 to the power of 7 times 0, which equals 0. I don't want to use that because that's just way too much. That value is way too much. Same thing here, 64. 35 is less than 64. So if I have this as a 1, then 64 goes into my calculation. I don't want 64 in my calculation. It's too big. So I put zeros there. Now 32 though, 32 is less than 35. So since 32 is less than 35, I definitely want to have a 1 here because I want this to be involved in my overall calculation. So you can see what we've done there, 2 to the power of 5 times 1, so that's 32 times 1. So right there, I'm using a value of 32. So I have 32 in this case. All right, let's keep moving on from here. So now I have 32, and I have to consider 32's already been used. So 35 minus 32 is what? 35 minus 32 is what? It's only 3, right? So essentially now, I don't really care about the 35. I care about the fact that I have 3 left over. That's the 35 minus 32. Gives me 3 left over. So now I'm comparing 3 to 16. So 0? Nope. Right? We don't want 16, right? Because 16 is way too much. Right? We're trying to figure out how 3 fits into this now. So 8, still too much. So we want this to be left as 0. 4, that's still too much. So we want this to be left at 0. But 2, wait a second here. We have 2, and 3. Is this 2 less than 3? Is the 2 less than 3? Right? That's why we crossed out the 16, the 8, and the 4. 16's greater than 3. 8's greater than 3. 4's greater than 3. but 2 is less than 3. So since 2 is less than 3, let's go ahead and put a 1 here. So I've put a 1 there now, so that means I'm going to use that in my calculation. So 2 times 1 is 1, so we're going to go ahead and put our 2 here. Now, since I've used the 2, I got to take that away from my 3, so I no longer care about the 3. I now have 3 minus 2. I now only have 1 left over, don't I? Yeah, 1 left over. So with 1 left over, well, I only have 1 here. Is 1 less than or equal to 1? 1 is equal to 1. So we definitely want to use this 1. So we're going to use this 1. We're going to drop it down here. 1 times 1 gives us our grand total of 1. So our 1 in binary. So we have 1. So now we have 35 is equal to 32 plus 2 plus 1. So what is the binary equivalent? The binary equivalent of 35. It is 0, 0, 1, 0, 0, 0, 1, 1. Why? Because 32 plus 2 is 34 plus 1 is 35. So that's all we're doing here. That's all we're doing here. Is we are trying to figure out which of these combinations of 128, 64, 32, 16, 8, 4, 2, and 1 is going to equal 35. Well, 128 is too big, 64 is too big, 32 works. All right, so then that leaves me with 3 left over, 16 greater than 3, 8 greater than 3, 4 greater than 3. Ooh, 2's not, so that's going to work. So now we take 3 minus 2, we get 1, and then we have 1 also involved in the picture. So 32 plus 2 plus 1 equals 35. So you're just trying to figure out that possible combination in order to get the 35, which is 0, 0, 1, 0, 0, 0, 1, 1.